Hello everyone, welcome in the second part of my course Microservices with Spring Boot and Spring Cloud. Today we'll talk about distributed configuration and service discovery. Here is the plan of our presentation. We have pretty many topics to discuss. I'm going to start from a short overview of Spring Cloud approach to releasing new versions of software. Since Spring Cloud consists of many independent projects, it does not force them to use the same version numbers, but it is grouping different versions of these projects into a single release train. The release trains have names, not versions, to avoid a confusion with sub-projects. The names are allocated in an alphabetic sequence, so you can sort them chronologically. For naming these trains, Spring Cloud uses the names of London tube stations. That's why the first release name was Angel, the second was Brixton. The current newest release train is Hoxton, and we'll use it for our sample source code. After this short introduction to releasing, we'll proceed to running Spring Cloud config server. With a config server, you have a single central place to manage external properties for applications across all environments. The default implementation of the server storage backend uses Git, so it is easily supports label versions of configuration environments, as well as being accessible to a wide range of tooling for managing the content. Git backend is a really nice option, but I decided to demonstrate how to use two other of available formats: file system backend, also called native, and Vault backend. With file system backend, you are storing application configuration files on file system or even on ClassPad. Maybe it's not the best option for production, but it's great for tutorial. Vault is an advanced tool from HashiCorp for managing secrets and protecting sensitive data like passwords or keys. I'll show how to integrate it with Spring Cloud config server in order to allow application to use properties stored there. Every Spring Boot application can be integrated with config server through Spring Cloud config client. I'll show you how to integrate our sample application with config server in order to use properties stored in both file system backend and Vault backend on the server side. After discussing distributed configuration, we will proceed to the examples of using service discovery. We are going to use Eureka server from Netflix. Currently, we have very interesting situation with Spring Cloud Netflix project. Since it is still the most popular and recognizable project of Spring Cloud, most of its components has been moved to the maintenance mode more than 1 year ago. The tools like Proxy, Ribbon Client, or Hystrix has been replaced with the competitive Spring Cloud components. The only component that has not been moved to this maintenance mode is Eureka. I'm going to show you how to build and run Spring Cloud Netflix Eureka server and how to integrate our Spring Boot application with it using Spring Cloud Discovery Client. We will also analyze some more advanced discovery settings and their impact to the communication between Discovery Client and Eureka server. Spring Cloud config is not the only option for distributed configuration with Spring Cloud, and Eureka is not the only one option for service discovery. Spring Cloud provides some other solutions that may be used for both service discovery and distributed configuration. Those tools are Zookeeper, Alibaba Nacos, and HashiCorp Consul. I'm going to show you how to run Consul in development mode on Docker container and how to integrate our Spring Boot application with it using Spring Cloud Consul project. Our application would be able to register itself as Consul service, would be able to read properties from Consul key value store, and finally refresh property values after modification. After watching this part of my tutorial, you'll be able to use the most popular project of Spring Cloud efficiently in your development. Moreover, you can even try to run your first microservice in production, since you would understand such mechanisms like service discovery or distributed configuration, and you would excellently know how to use them in practice. Let's proceed to the first topic, release trains. We take a look on Spring Cloud documentation site. There is an interesting table with release train history. As you see here, the current release train is Hoxton. It is released with version 2.2 of Spring Boot. The previous release was Greenwich, and it has been used version 2.1 of Spring Boot. If there are some critical bugs in those releases, the release train will be published as a service release with names ending with SR. For example, the latest service release of Hoxton is SR3. The releases before Edgeware are not supported. Edgeware will follow the end-of-life cycle of Spring Boot 1.5. Now, let's switch to IntelliJ. The release train is managed as a bill of material, and it is included to Maven POM XML in dependency management section. We are using the newest service release of Hoxton, SR3. After adding release train, we may proceed to the implementation. We are starting from a configuration server. Now we navigate to Spring Server module. In fact, config server is just a simple Spring Boot application that includes library Spring Cloud config server. We also need to enable it in the main application class or configuration class by using annotation enable config server. The next step is to enable native mode instead of Git, which is used as a default backend. To do that, we should activate Spring Boot profile with name native. We can do that inside Bootstrap or application properties file. After that, we can add specific property files for our sample application. First, I'm creating a directory inside config server for storing property sources. Then I'm creating application YAML file. It is shared between all applications that connects to config server. Now I'm adding the property responsible for enabling dynamic port allocation. You probably remember a previous part of my course where I demonstrated this feature of Spring Boot. We are also creating a file with specific configuration for a single application, call me. I'm adding the property 1 and property 2. We'll set a significant values to easily recognize which of them is used, like app specific property 1, app specific property 2. We'll also add the same two properties to our application name. We are setting values generic property 1, generic property 2. We are going to run two microservices, call me service and caller service. Now we are creating Bootstrap inside call me service. The name of such file inside config server should correspond to the name of property Spring application name inside application properties, so we need to set it. And now we are moving back to the configuration server. We are running application. As you see, it is starting on the dynamic port. It is not exactly what we wanted to achieve. Now we check the config server response for our sample application. On dynamic port, we are inserting its name and the default profile name. As you see, it only contains a specific application YAML file without a global configuration. To avoid that problem, we need to add a specific locations of configuration files, which is different than a default configuration path. We are setting config repo. As you see, here is the defaults for search location, and it is a config directory, so we need to change its name to the config repo search in bootstrapping file for config server. And now we are running the application once again. We need to wait a moment, and now as you see, it is starting on port 8080. Now we may move back to the test on the terminal, and we are running a curl command for 8080 port now. And as you see, our configuration server now returns a specific configuration file and a global configuration file for all applications. After running server-side application, we may proceed to the implementation of microservices. We are starting from call me service. First, we need to include Spring Cloud config client starter to the Maven dependencies. The client comes with auto-configured address of config server. It is localhost on port 8888. Since we are running Spring Cloud config servers on default Tomcat port 8080, we need to set the right address using property Spring Cloud config URL. As you see, here is the name of our application. It's call me service, and the name of configuration file inside config server should correspond to that name. We are changing the address of configuration server. We will also provide an implementation of HTTP endpoint that returns the value of two properties taken from a config server, property 1 and property 2. Before adding it, we should include a Spring Boot starter for web application that comes with a predefined list of dependencies for building REST endpoints. Now we are creating this controller, which is prefixed with call me, and now we are adding properties, property 1 and property 2, and injecting values from configuration file using value annotation. And then we are exposing these properties outside our application using REST endpoints. There are two endpoints, property 1 and property 2, prefixed with call me. And now we are running our application. As you see, it is listening on dynamically generated port that has been set in global shared properties file. You can also see in the logs that it is fetching two resources from configuration server, a global configuration and a configuration dedicated for the application. Now let's call our test endpoint returning values of two sample properties. As you see, the properties from application specific source are preferred over properties from a global source. Now we are going to implement a next microservice, caller service. As you see, it does not have a specific configuration file, so it uses only a global configuration file. Now we are adding a controller class. It's the same as a controller inside call me service. It also injecting two properties taken from configuration files. It's prefixed with caller. And now we are running the application. It is also listening on the dynamically generated port. But as you see here, it only uses a global configuration inside application YAML file exposed by configuration server. Now we are running those two, we are testing those two endpoints, and property 1, property 2, they are returning a generic property taken from application YAML. In the next step of our tutorial, we will discuss Vault Backend. Vault is a tool from HashiCorp.
We are going to run Vault using its official image from Docker Hub. The image version is 1.4.0, which is also tagged as latest. We are exposing HTTP API on port 8.2.0.0. The image is run in development mode. This runs completely in memory Vault server, which is useful for development but should not be used in production. In that mode, we may define a value of root token using Docker environment variable. That token then may be used for authentication against Vault. Now, let's run our container and take a look at the logs. Vault prints detailed information about the instance. The value of root token is Spring Microservices course. Now, let's switch to the web browser and navigate to Vault UI available under port 8.2.0.0. We are using the currently set token for logging to web UI. Key value engine is already enabled in development mode, but its version is 2. In fact, the Vault is providing two versions of KV API. By default, Spring Cloud Config is using version 1, but we can easily switch it to version 2 by setting a property inside application properties. We can also enable version 1 of key value on Vault. To do that, we should remove the current version of secret. We may easily do it using UI. After it, we may enable version 1. It's convenient to use secret name because it is by default used by Spring Cloud Config server. Web UI also allows to use Vault CLI commands directly. We are executing the command for adding new secret caller service with two properties, property 1 and property 2. After adding it, we can verify if properties exist by navigating to Caller Service Secret. Since two required properties already exist, we may switch to IntelliJ to integrate configuration server with Vault. To enable Vault for Spring Cloud Config Server, we just need to provide some additional configuration. First, we have to activate Spring Profile Vault. As you see, it is already using native profile. After change the config server, we'll be able to use both property sources, File System Backend and Vault Backend. Because I'm running Docker on virtual machine, which address is different than auto-configured, we also need to set property Spring Cloud Config Server Vault host to the virtual address of Docker machine, and finally we may restart config server. As you see, it is already enabled native and Vault profiles, and it is starting the application. Send some test requests. Let's call endpoint for the second application caller service. As you know, the endpoint requires authentication. We need to set HTTP header xconfig token on the request. We need to provide their Vault root token, and after that we are receiving a response from the config server. As you probably remember, the application caller service didn't have dedicated configuration on native profile, so it is injecting global property source taken from File System Backend and also currently configured property source on Vault. Since config server HTTP endpoint requires authentication, we would have to provide token on the client side. Let's switch to the caller service source code. We just need to set token in Bootstrap properties file. After that, let's start caller service application. As you see, it is listening on dynamically allocated port number. We are calling caller service endpoint that returns value of properties taken from Vault. Of course, we may set token anywhere else, not literally inside application properties file. For example, as environment variable or as a VM parameter of running application. As you see, it is returning a properties taken from Vault. Now I'm showing you how to set the token using VM options in edit configuration inside IntelliJ. We are setting a Spring Cloud Config token value, and now we can remove it from configuration and restart our application. You'll see that everything works fine as before. It is also possible to configure Vault authentication on the config server. Thanks to that, we won't have to set it for every single microservice. We just need to add some additional properties to Bootstrap YAM of the config server under path Spring Cloud Config Server Vault. After, as you see, we are adding authentication and the value of Spring Microservices occurs as a token. After restarting config server, we may call its endpoint for returning property sources. And you will see that it does not require setting xconfig token here on the request, since it authenticates in Vault by itself. You can compare it to the previous request without this authentication. It's all about distributed configuration. Now we may proceed to Discovery Server. We are creating a dedicated Spring Boot application for Discovery. The same as for config server, it is just a simple Spring Boot application with embedded Netflix Eureka server. First, we need to include starter with Spring Cloud Netflix Eureka server in form XML. Then we need to enable it in the application main class by annotating it using enable Eureka server. We'll also set a number of ports for application In order to be different than default 8080, we are using 8761, which is usually used as default port for Eureka. After all these changes, we start our application. Although there are some exceptions visible in the logs, the application is started successfully. The exceptions occur because Eureka tries to fetch registry before it starts. It is not needed when running in standalone mode, so we should disable that feature in configuration. To do that, in the server properties, we need to add two properties. Let's switch to the application configuration file. As you see, these are register with Eureka and fetch registry. Both of them are set to false. These are properties of Eureka client. And now we are restarting our application to see that there is no error in the log. It just brings a warning that Ribbon is already in the maintenance mode, but we are still using it in Eureka server. Start, we might take a look on the web URL provided by Eureka. It just brings registered applications and a history of registrations. The next step is to provide configuration to register our applications in Eureka. We are using Discovery Spring Cloud Discovery client for it. Okay, we are going to config server. In the previous step, it has been not discovered by the applications, and now we are going to register it in Eureka servers to be available for other applications through Discovery. We are adding Spring Cloud Netflix Eureka client, and as you see, our application is starting and config server is registering itself using Spring Cloud Discovery client in Eureka server. As you see, it is already registered. Now we are going to do the same thing for both two applications, Call Me and Caller service. We are also adding their Netflix Eureka client. The only difference with config server is, of course, a port number, since our applications are using dynamically generated port number. So as you see, they are registered with number of port, which is 0. And now you see that Call Me service application is registered in Eureka. I'm going to enable location of this in Discovery of configuration server. We need to enable Discovery for Spring Cloud config client. We also need to override the service ID, since config server is registered under different service ID than auto-configured. And now, as you see, the configuration has been fetched by the application based on the Discovery, since it started on dynamically generated port. We can send some test requests, but before, let's take a look on the Eureka API. It is exposing some useful endpoints. Here is an endpoint for getting all the registered applications. We can also call an endpoint that prints only a single selected application, in this case config server. Okay, in the next step we are going to discuss deregistration from Eureka. If we are killing our application gracefully, the Discovery client is deregistering application from Eureka. To down our application gracefully, we will enable shutdown endpoint. Shutdown endpoint is of course a part of Spring Boot Actuator. After adding this actuator, we need to enable shutdown endpoint, which is disabled by default, and we also need to expose all the actuator endpoints outside our application. After that change, we are restarting the application. As you see, it has been started on dynamically allocated port. We are copying this port, it is 50536, and now we can call endpoint responsible for graceful shutdown of our application. It is actuator shutdown. If our application is stopped gracefully, now you will see that it is almost immediately shut it down and deregistered from Eureka server. We can verify it in Eureka UI, and also let's take a look on the logs generated by the client application. As you see, it has been already deregistered from Eureka. Interesting what would happen if we are killing our application with force option. And we can also try to verify this scenario. We are starting call me service application once again, and as you see now we are killing it with force option. As you see, the application is still visible in Eureka. It were not some reasons for such a situation. Eureka runs the epic task in background. This task is responsible for checking whether heartbeats from the client are still being received. Let's take a look on the logs. As you see, it is fired every 60 seconds. It can be easily changed in application configuration properties. Without changing it, even if we change some other properties, the service instance might be removed at worst after 60 seconds. We are using eviction interval timer in MS, and we are setting it to 3 seconds. It is set in milliseconds, and after that we are restarting Eureka server. Now as you see, evict task is run every 3 seconds. We also need to change some properties on the client side. Let's switch to Bootstrap YAML in the call me service. We are running 2 properties there: lease renewal interval in seconds and lease expiration duration in seconds. With these values, our application will send heartbeat to the server every second, and the server will remove the instance of application if it will not receive a heartbeat after 3 seconds, so after the 3 attempts of application. After those 2 changes, we may restart our microservice. You will see that if we kill the application with force option, it is almost immediately removed from the server. We can take a look on the logs from Discovery server. As you see, it is removing call me service. Now we may back to the UI, and there's no call me service registered. Now let's analyze another aspect related to Discovery client. If we are running application on dynamic port, we need to set 0 as server port. Let's take a look what happens if we run 2 instances of caller service. First, let's enable parallel run in IntelliJ. After that, we may run 2 instances of our service. Both of them are running on the dynamically generated port number. And both of them have the same instance ID. You can switch to UI and see that there is still a single instance of application registered in Eureka, since it has just been overridden by the current round to the same instance ID. You have to override the value of instance ID on the client side. There are many possible solutions, but I will just change the default value by adding randomly generated string. The current instance ID is visible in the logs after startup. Let's restart both instances of caller service. And now you see, it is suffixed with randomly generated string, and it is different for the first instance and for the second instance of our application. We may refresh the UI and you see there are two instances of caller service registered. The last topic in this part of the tutorial is Consul. I won't show the advanced usage of this tool. I just want to demonstrate how you can easily switch your application from Eureka and Spring Cloud config to Consul discovery and key value as configuration store. We are running Consul on Docker container in development mode. We are using its official image from Docker Hub. The API and Web UI are exposed on port 8500. Since the container has been started, we may take a look on the logs. As you see there, the current version of Consul is 1.7.2. Now let's switch to Consul Web Console. As you see, you may figure out there the list of registered services and the properties available in key value store. To integrate our Spring Boot application with Consul, we need to include some dependencies to POMXML. We have two options. We may include a single dependency Spring Cloud started Consul all, or just two dependencies separately for discovery and configuration. After that, we are commenting out Eureka and Spring Cloud config client dependencies. If Consul is running on different hosts than auto-configured localhost, we also need to override this address in application properties. It is the address of virtual machine of Docker. Before starting application, we prepare configuration source. We are using YAML format in Consul. I'm going to create some configuration as for examples, the same as for examples with Spring Cloud config. I'm setting the dynamic port in the global property source. And I'm adding two properties, property 1, property 2, in the dedicated configuration for each application. The configuration is to have a proper path. The default configuration on Spring Cloud Consul requires a path with prefix config and suffix data for YAML format. We are running property Consul property 1, Consul property 2. Those properties are injected into the application, the same as in the previous examples with Spring Cloud config, Vault and File System Backend. The properties has been added. We may switch to IntelliJ. Now we are setting the right format. In the application settings, it is Spring Cloud Consul config YAML property set to YAML. Now we are starting the application. Our application is able to detect all the property sources inside Consul. As you see, it has been started on dynamically allocated ports, so it reads the configuration. And now we can start the second instance of our application, the second microservice, caller service. It is also running on dynamically allocated port. Now we are going to call the same test endpoints with configuration as for the previous test, and as you see, now it returns Consul property 1 and Consul property 2 taken from Consul. Okay, two applications have been registered in Consul. As you see, It's unable to call health check since I'm running Docker on virtual machine, but the service is running on localhost. There's no sense to register health check in that case. We should also override the instance ID. The reason is the same as for Eureka server. If we are running two instances of applications, we need to have a unique instance ID also in Consul. And now we are starting our applications. Now we may move back to Consul Web Console. The second instance of Call Me service has been registered. It hasn't registered health check and uses randomly generated number as ID. As you see, there is no errors there. This is the end of this part of tutorial. See you soon.